These are our pre-calc notes for 06 matrix operations. So this section is just designed to give you a little bit of information about matrices and then just do some basic matrix operations. So the first thing about matrices is we can tell it's a matrix because I have a capital letter identifying it. That's kind of a normal thing we do for matrices. And then I have these brackets, and then I have like this grid of numbers. And so these numbers could be used to identify a shape. They could be for like X, Y, and Z. They could be for equations like that. But we can organize information this way. And because like if I was doing, like I'm saying a system of equations, if these numbers stood for different letters, it just saves me from having to write some of that out. So instead of like an 8x or a negative 2y, I just have numbers now. So it makes it easier to work on them and operate with them. So with matrices, I have rows and columns. I always like to just review that my columns are up and down. So columns go this way and my rows go across. And your textbook and Glencoe, they describe this with M's and N's, talking about the rows and columns. We always say rows first and columns second. And so I just prefer to use R and C because when I think of RC, I think of remote control and they just kind of go in that order. So it's easier for me to remember. So when we talk about dimensions of a matrix, we're talking about the rows by the columns. So in this case, I have 3 rows and I have 4 columns. So this would be a 3 by 4 matrix. The other thing that you'll notice is we talk about how each number in this matrix is an element. And so, for example, if we're looking for this element right here, it says 32. That means we've got row 3 and column 2. So for number 1, we're just going to go through and we're going to find the value of one of our elements and we're going to state the dimensions. So when I look at A, I have 2 rows, and I have 1, 2, 3, 4 columns. So this is going to be a 2 by 4 matrix. And since we're doing notes, let's just add some more information in. So 2 rows by 4 columns. So remember, it's always RC. And then when I want to find an element, let's see, we want to have the second row and the 4th column. And so that would be 4. So I feel like that's just some pretty basic stuff. So next we have some vocab about matrices. So not stuff that we're going to be using a lot. Square matrix, because we have the same number of rows and columns. So it doesn't have to be a 2 by 2. It could also be a 3 by 3 or a 4 by 4. Also 3 by 3. I said 3 by 3, but I did not write that. 4 by 4. So square matrices can be different sizes. It doesn't have to be a 2 by 2, but it is a square. So we've got the column matrix, the row matrix. Zero matrix, I think, is pretty easy. Every element is 0. So next we have a little note about equal matrices. So matrices are equal only if all of the elements are equal. So in our first row, first column, we have a 2. Our first row, second column, we have a 4. All of those elements are equal, so we have equal matrices. So big ideas today are like, what is a matrix, right? It's organized in this grid. We've got these brackets around it. We use a capital letter for it. And then part of what we're doing too is just this kind of background vocab on matrices, and then what kind of rules do matrices follow. So one of the things that we know in math about our regular number system is we know how we can add, subtract, multiply, and divide. We know how all of that stuff works. But just because it works one way with our regular real number system doesn't mean that it follows those same rules for matrices. So that's what we're kind of investigating today. So adding and subtracting matrices. A little bit of info here. In order to add and subtract, you must have the same rows and columns. So I'm just going to write RC. So the dimensions have to be the same. We add elements in the same position or subtract. And I prefer to never subtract, actually. So if I have subtraction, I just go through and I change subtracting to adding the opposite. So I'm going to add that also. Or add the negative. Add the opposite is more mathematically correct, but I know a lot of times students just talk about changing. We just change the sign, right? So for A, we've got A plus C. So when I'm doing work for matrices, I always write down first what I'm doing. So I'm going to write down A plus C. This is how I would show work. And then I'm going to actually copy down those matrices. And I know at first just writing them is really awkward. We're not used to organizing all these numbers and having these brackets around everything. So what I notice here is that my dimensions are not the same. I have a 2 by 2 matrix, and this one's got 2 rows and 1 column. So I can't add. The dimensions are not the same. We can't do this. Can't add. Dimensions are not the same. So if you want to write not possible, that would be another way you could write this. You don't have to give me a lot of information. For part B, we're doing B minus A. And B and A I see are both those 2 by 2 square matrices, so we'll definitely be able to do this one. So B goes first. And then minus A. So again, first I wrote down what I'm doing with those capital letters that denote my matrices. And then I copy them down. And because I'm subtracting, I really want to go through and I want to bring that subtraction to everything in that second matrix. So I am going to copy the first one down again. You could really just do this in one step, but I'm trying to make sure that this is really clear. And then I want to make it a -2, a -5, a +1, -3. So I changed the sign on all of them, and this is a plus. And now I can just add instead. So when I add, I'm adding things in the same position. So I'm adding the 10 with the -2 because those are in the same spot. 10 plus -2 makes an 8. So in my answer matrix, it's also going to go in that upper left-hand corner. And then I'm going to add the -2 with the -5, and that's going to go in the upper right. So that'll be a -7. So you're really just going through and you're adding up all those numbers that are in the same places. So I think that one is pretty intuitive, kind of makes sense. A lot of what we're doing today is going to make sense. We'll look at stuff that's a lot more difficult tomorrow. This is just really kind of background easy stuff today. So for scalar multiplication, and that's what we call it when we're just multiplying by one number. So on this one, I have a -3 in front. So when I do scalar multiplication, what I'm really doing is I'm distributing that number to all the elements. So I'm going to write distribute to all elements. And so that means a -3 times the 1 and the 5 and the 0 and the -2. And when we do that, we're keeping everything in the same spot. -3, -15. So scalar multiplication is pretty easy. So I've hinted already that matrices might not follow all of the rules that we're used to in math. But you can see that there are a lot of rules that they do follow. They do follow the commutative property where I can add in any order, associative property where I can add 2 and then I can add this one, or I can do it in a different order. And then if I have like a scalar multiplication, so this is just for scalar only, I could add my matrices and then multiply, or I can distribute and I could multiply that number times both of them and then add. So they do have some properties that they follow. But we cannot assume that matrices follow all properties. So for this one, what we're going to do is we're going to, let me just move this up really quick so I have some room to work. We have 3 times A minus B. So we could distribute. We could do 3 times A minus B is 3A minus 3B, but that's going to be more math problems, right? It's equivalent, but it's not necessarily more efficient. So I'm going to just do these in the order of operations instead. So I'm going to subtract first and then multiply. And the reason I'm going to do that is because if I subtract first, that's one math problem. Multiplying is a second math problem. But if I do 3A minus 3B, like that's a problem. I have to do 3 different steps and the numbers are going to be bigger to work with. So just because you can distribute doesn't mean we want to. So I'm going to write a 3 here. And I've got to write down my A and my B. And be really careful that you put them down in the right order. A minus B, they give them to me in the right order, so that's kind of helpful. Minus, let's see, B. You're going to want to really keep everything organized and be careful with your signs. It's not a bad idea to just look things over and make sure you copy the right numbers down. So the first thing I want to do is change that second matrix to adding a negative instead. So now this is going to be a plus, and this would not have to be a separate work step. I could just kind of do this all at once. But I'm trying to make sure that my work is really easy to follow. Okay, and now I'm going to go ahead and add. So we're just adding elements in the same spot again. And then our last step is going to be to go through and multiply everything by 3. And there's our answer. So our last problem is a little bit different. We have some matrices. We have A, we have B, and they want us to solve 2x minus A equals B for x. So I don't want to substitute my matrices right away. I want to do my solving for x part without plugging those in, because as soon as I put those matrices in, this is going to get a lot busier. So I'm just going to go ahead and solve for x right now. So to solve for x, I would add A on both sides so that 2x equals A plus B. And I know normally we'd think about dividing both sides by 2, but with matrices, I don't really want to divide by something. I want to have multiplication. So instead, I'm going to think about multiplying both sides by 1/2. So x is going to be 1/2 times A plus B. So this is like that scalar multiplication. So I don't want to write it as A plus B over 2, because we just don't do that with matrices. Instead, we're going to multiply by 1/2. So if x equals 1/2 times A plus B, that's what I have to do now. So I'm going to do exactly what I did on the last one, where first I'm going to take A and B and add them. So let's see if I can actually fit this in. I feel like I didn't give myself quite enough space here. So there's matrix A, here's matrix B. And then after we add, we're going to multiply everything by 1/2. So when I add, I'm adding things in the same position again. So let's see, it's going to be 4, 2, negative 2. And then I'm going to go through and multiply each element by 1/2, which is the same thing as dividing each element by 2. Remember, we talked about that, but with matrices, we don't have a way to write this divided by 2. So instead, we put a 1/2 out front. So this is going to be my answer. So this is it for our 0-6 notes. The next section that we have, we're going to learn a lot more about matrices, and it's going to get a lot more difficult. But for today, this is just kind of basic adding, subtracting vocabulary, and then that cautionary word about being careful. Matrices don't always do everything that we think that they should. So we have to be really careful and pay attention to the rules we're given.